I am going to show you now how to obtain the transfer function of a system in an automated way using the bond graph modeling technique. We see a circuit that you see on the screen right now, a simple circuit. We're going to make the bond graph model of that circuit, and then we're going to use the CAMG software to be able to obtain the transfer function of the voltage C in relationship to the input voltage. That's our objective. So right now we're going to close this and we say, okay, the way we model this in using this technique is we follow some steps in here. The first thing we're going to do is to use a one junction for the current. So we use the symbol to signify the current that we have in here, the I in there, okay? And then we put the elements that are attached to this current. So let's write down and so that those steps are very well defined and you can remember them later on. Right, so we're going to say steps. I like steps in here. So one. See, we for making the, I would say use a one junction for each distinct. This is for the electrical circuits, okay? Current. That's what we just did. Then you could say attach the elements that experience that current. Step number 3. So we attach them with the bonds in here. In this case, you have this is we make a little picture signifying our source of effort is voltage in here, and attached to this is the R element with value or whatever it is. Then we have the C element in here with value, C. And then on the bottom one, this is the I element with the value of the inductor. So we attach the elements as they experience the current. You can say, in this case, we don't have a relative currents. You could say if relative, if elements see the difference in currents, I will not see experience. Here we use zero junctions. And then you will say enter the bond graph in CAMG. And fifth, let CAMG find the transfer function. Isn't that simple? This is the idea. So I am going to do exactly what I just said here. I'm just going to go on put my bond graph model in here. And I am going to let the computer do something. Let me just move it a little so that You could actually see it. Okay, very good. I am here. So I am going to go here and say File, New, and then I am going to actually draw this little picture on the screen. And the order in which you enter the elements is not important. I could just do first the SE and then put the 1 next like this, and you say this connection is from here to here. Then I put the element R element at the top in here. The connection is from the 1 to the R. Then I put the C element, which signifies the capacitor. Same thing, I keep connecting this, and then I connect it like that. Yeah. One thing that we need to keep in mind is the computer assigned these numbers, and using this picture, we should be able to recognize what the elements are and what the voltages are, just to so that we have a record of what we're doing. I am going to go ahead and do a couple of things. First of all, I want a picture of my graphing here. So I am going to put that into my notes that I'm doing. My notes are over here. So what we entered on the computer was this, right? So what I'm trying to say is now you need to read this picture. Like in this case, C is for this C. The variable E3 is the voltage of C, and the variable E1 is voltage V here. The variable R2 is this R, and the variable I4 is this L. Having said that, I am going to go in here and I say, okay, look, what I really want is that you interface with MATLAB in any way you can, and tell me, give me this model in such a way that MATLAB can find me the transfer function. In other words, CAMG is going to create a MATLAB input file or set of files, and the two programs connect with each other. You don't have to be restarting MATLAB or anything like that. They are automatically linked. And so when you have this connection in here, you get immediately the results. Now you are in the MATLAB environment. Now we need to learn to read this. CAMG produced these 4 files. Yeah. This CAMG mod stands for model file. That's the file where you put the values. This CAMG-Q is the equations file. This CAMG is the symbolic file, CAMG-SYM. And CAMG-num is the numeric file. For the purposes that we want, we're going to look at CAMG-num. CAMG-num file. And in here, we need to define what the output is, because without that we cannot do it. So we're going to say find. I told you it was E sub 3 is what we want as the output. So the computer went and found it where it was. It has, see, these question marks. In MATLAB also, this percentage signs make as if this would be common. So we need to let the computer know this is my first output, and it's going to using the state space form, I am going to use the first row of the matrices C and D to find the transfer function. In this case, even if you haven't reviewed the state space form, that should not be a problem, because right now you're going to say to the system, find the transfer function here. There is one thing that I saw on the MATLAB in this new version. One of these two statements doesn't quite work, or they have changed, but let's experience, let's see what it does. So I asked the system what the output, I specified the output. The computer gave me the state variables, what the output is, and so it keeps going in here, and it says, just remember that statement that I told you, the new version doesn't like the simple, but simplify, I think, is the one that so we might have to, yeah, right there. It doesn't like it. This no longer is active on the new version. So let's just do it again. See, run it again. And sure enough, it gives me the transfer function, see? But this time, automatically. So if you want to have it like we did before, we need to put the numbers. But you see, in symbolic form, it gave me 1 over C. This is C times L, and this R times C plus 1, exactly as we had it before. But in here, what I can do is I could come into the file and put some numbers in here, and the computer will actually do the calculations for me in numeric form. So I need to activate these two to put the numbers. This was a 1, right? This was a C was 1 too. Which one was the one that was 0.5? R was 0.5. And I was what? This was 1. Okay. So now if I do it in numeric form, yeah, I do it again. See, now I have the transfer function in numeric form in there. And now if I press it in here, the computer is going to go automatically and obtain the step and impulse response. In fact, there is one. You see the step and impulse response right there, automatically. So that's the other method, is the automated method. As you can see, we get the exact same answer, but we didn't have to derive any differential equation nor apply the Laplace transform, because all that is in the computer program. The CamG and MATLAB do the handshake in such a way that everything that CamG directs is already in that form. So that's how you do it.